Welcome to the Bentley Systems training course where you will learn how to design steel connections using RAM Connection Standalone. RAM Connection Standalone is used for the design and detailing of steel connections to design individual shear, moment, brace, splice, and truss connection types for a variety of different steel design codes. In this series of videos, we'll be focusing our attention on the steel connection design workflow for designing shear connections for a variety of different beam to column and beam to girder joints. In RAM Connection Standalone, different joints and different connection templates are compatible with certain types of member properties and framing options. All of these options are considered when we set up the joints that we'll be using to demonstrate the shear connection design workflow. For this video, we will be focusing our attention on single plate shear connections for both beam to column and beam to girder joints. We will now turn our attention to RAM Connection Standalone, where we will assign a single plate shear connection to both a beam column joint and a beam girder joint. Currently, I have joint number 1 selected. This is a beam column flange joint with a shear reaction imposed upon it. When I'm ready to assign a connection to this joint, I can select the Design tab in the ribbon toolbar and then click on the Assign icon. Once invoked, the connection assignment dialog will appear on your screen. In the filters area, you're going to notice that the joint that you currently have selected is already selected by default. But in addition to that, I'm also going to select the workflow that I'm most interested in for this particular connection design. The first option is a basic connection workflow. Now, in a basic connection workflow, connection templates are included in the program and are ready to use. When using a basic connection workflow, RAM Connection will search the predefined connection database until it finds a connection that works well for the joint according to the defined geometry and loading. Alternatively, I could also go with a smart connection workflow. In this workflow, connection templates are provided where RAM Connection will determine and optimize the main connection components such as the connector size, number of bolts, and also size of welds. For this particular example, I'm going to go with a basic connection workflow. Once selected, I can select the shear connection type I'm most interested in. For this example, I'm going to select SP for single plate. Once done, let's go ahead and click the Assign button. And with a basic connection workflow, the program will search through the predefined database until it finds a connection that works well for both my geometry and loading. Here you can see that it successfully found a connection template. It's a shear plate for beam column flange. It has chosen a 1/2 inch plate with 4 1-inch diameter bolts. Let's go ahead and click Close in this dialog, and we should be able to see our connection has been assigned, and we will see some additional connection information available in the main view window. In addition to that, let's take a look in the joint selection area. Here we can see the interaction ratio and a load case or load combination. This will reveal the status of your connection design. Now in this area, you do want to make sure that you're taking a look at the critical load condition. This would be the load case or combination that resulted in the highest interaction ratio on this connection design. I know that I'm looking at that for this particular example because the critical load condition icon is currently active. So with that information, I could see that design load combination 2 yielded the highest interaction ratio of 0.87. This interaction ratio is less than 1, and it's indicated in green, meaning that no errors or warnings were encountered during the connection design process. If I wanted to review any of the connection information or possibly modify it, you can edit any connection within RAM Connection Standalone. To edit a connection, we can go to the Design tab in the ribbon toolbar and click on the Edit icon. This will allow you to edit the connection that's currently selected in the joint selection area. It is a shear connection, so I'm going to select Edit, Shear Connection. Now when you're editing any connection in RAM Connection Standalone, the connection pad will appear on your screen. And you'll see a variety of different parameters that are currently assigned to this particular joint and connection. What you're going to notice is the symbols also that are available in some of these fields. If you see a blue arrow adjacent to a particular field, that means that that is a parameter that was defined most likely through the joint definition area. Those types of parameters can be modified here to review the results of the connection design, but those changes won't be saved to the connection template once you exit out of this screen. The reason for that is because this information belongs to the joint data, and that's where that information should be edited. Anything else, however, you can go ahead and edit here and save in the connection database. This would include things like thickness of plates, number and size of bolts, type of bolts, and so forth. So here in this single plate area, I can go ahead and see all the information that I can modify. Here for this example, let's go ahead and see if we can select a different size and type of bolt that would still satisfy the connection design. Here I'm going to select a 3/4 inch A325 type N bolts from the United States Bolt database. Let's go ahead and click OK, and then we can see what happens when you change a connection design. Here you'll see your interaction ratio is updated, and you'll be able to see whether or not this new design passes the interaction ratio. Here I can see my interaction ratio is now greater than 1.0, and it's color-coded in red, which means an error was encountered, meaning an error was encountered during the connection design. So let's go ahead and return to our original bolt type. Now, in addition to being able to modify the single plate parameters within the connection pad, you also have access to the results and the DXF drawing. So let's go ahead and start with our results. So we'll go ahead and select the results icon. Here I will be able to see all of the steel connection information, including all of the geometry considerations and the design checks that were performed, along with their status. If I would like some additional information regarding the calculations, I can click on the View Formulas icon, and I'll be able to see all of the equations and variables that were used to arrive at these results. In addition to that, if I go over to the right-hand pane, I can see the DXF view. Here I'll be able to see all of the information that would be included in a drawing for this connection. I can customize this drawing, and I can also export this DXF to reference into my AutoCAD or MicroStation drawings. If you had made any changes that you wanted to save in the connection pad, you can click on the Save icon, and then you can exit out. Now that we've assigned our first single plate shear connection, let's also select a beam girder joint. Here I'm going to select joint number 5. This is a wide flange beam going into a wide flange column, going into a wide flange girder, and a shear connection has been imposed upon it. Let's assign a single plate shear connection to this joint as well. Through the Design tab in the ribbon toolbar, I will now click on the Assign icon. Here you can see that the beam girder joint has already been selected, and again I have the choice between a basic connection and a smart connection. I'm going to go with a basic SP single plate connection, and then we will click the Assign icon. Here we can see that the connection has been assigned, and in the joint selection area I can see that the connection template that was assigned has passed all code checks. Again, if I want to review any of the information or make changes, I can click on the Edit icon followed by Shear Connection. Again, I'll be able to edit any of the single plate information. I can also modify some of the coping information as well. Now in a beam girder joint, what we're going to notice is that the top flange of the beam and the top flange of the girder are flush. We do have some other options here. So here I can go with a beam girder alignment. If this wasn't my situation, I can go ahead and put centered or a variable distance. In addition to being able to modify the single plate information, such as the thickness of the plate or the quantity or size of bolts, we can also change a few other pieces regarding the configuration of this joint. Currently, I have this set to beam girder alignment at the top. That means the top flange of the beam is matching the top flange of the girder in elevation. You do have a couple of options here. We can select centered or variable distance instead, if that better represents the configuration that you have. In addition to that, for the plate type, we can choose between standard or extended. I'm going to go ahead and select an extended option. And I'm going to select the option for the beam edge inside support flanges. So here you can see I have an extended end plate and I've pulled this out. Again, it's going to update my interaction ratio when I make changes in the connection pad. At this point, I'm going to decide that I want to keep the original connection design as it was. So I'm not going to hit save. I'm just going to close out of the connection pad. It's going to ask me if I want to save any of those changes, and I'll go ahead and click no, and you can see everything reverts back to its original configuration. At this point, this concludes the process for assigning a single plate shear connection to both a beam column joint and a beam girder joint.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.